All right, hi guys. So today we are moving on from where we left off last time. So if you remember, we looked at factoring quadratic equations, which was a little bit of a review from Math 10C and some new information. So factoring with quadratic patterns and things like that. So today we're going to just kind of extend on that a little bit by looking at more complex questions. So how we can apply this to word problems. And that's basically what we'll look at today. So just a bit of a kind of reminder of what we looked at last time. What does it mean to solve a quadratic equation? So if you remember, that means we're looking for the roots or the zeros. And again, like I've mentioned on every video, if you guys want better written out answers, check out the filled in notes that I have posted. So you're looking for the roots or zeros. So basically, what are the values of x that make the equation equal to 0? So when we're thinking about on a graph, that means we're looking at the x-intercepts because the equation would be equal to the y value, which would be 0 at the intercepts. The next thing is, how can you solve a quadratic equation? So remember, we looked at a few different things. We looked at solving it graphically, where you would input the equation into your calculator and then use the technology of the calculator to calculate the x-intercepts. You can factor, just like we looked at in the last lesson. And we're going to get into this later, but you can use the quadratic equation. And we'll look at that in a future lesson. Use quadratic equation. Okay. What are the solutions to a quadratic equation called? So that would be the same thing as kind of this. So when you're solving a quadratic equation, you're looking for the roots or the zeros or the x-intercepts, and those are the solutions. Okay. All right, so let's look at a question here. A water slide ends with the slider dropping into a deep pool of water. The path of the slider after leaving the lower end of the slide can be approximated by the quadratic function, and then they give you the function, where h is the surface above the pool. So just remembering that what your function is going to be the y axis. So basically on the y-axis of your graph, you're looking at the height above the surface of the pool. And d is the horizontal distance that the slider travels from the lower end of the slide. So basically, they want to know what is the horizontal distance that slider travels before dropping into the pool after leaving the lower end of the slide. So with these kinds of questions, I think it's always best to start out by trying to visualize the scenario. So if we think about our graph setup, then like we mentioned, the height is going to be on the y-axis and the distance that they travel is on the x-axis. And then we're given a quadratic function to represent that. So remember, with a quadratic function of the form like d squared, like ax squared plus bx plus c is basically this format. That means we're always looking at a parabolic shape, okay? So if we know that basically the path of the slider is approximated by that function, if you think about if the slide kind of started here, and then the person's like come down this slide, and then they are going to like shoot out of the bottom and kind of go a certain distance, right? So this is what you would kind of expect their path to look like coming out the bottom of a slide. Now, of course, the other side of that is not going to represent the slide. So because it's a quadratic equation, we're going to see a mirrored parabola on the other side. Okay, so and the reason why I started here for like where they're dropping off is because distance is on the x-axis and here distance is 0. So at a distance of 0 from the slide, you're basically like coming off the end of the slide, and then you shoot off and fall down. So once you can visualize the scenario, then you can start looking at solving your equation. So basically, what we would need to solve for is wherever these people land, right? Because they're looking for what is the horizontal distance the slider travels. And remember last time we talked a little bit about when you're looking for distance, you need to make sure that you know which 2 points on the x-axis you're calculating between. So obviously we want to know when they hit the surface of the pool, which is pretty much what you would assume is going to be the y-axis. So that's going to be some value d and 0. And then because, like we said, at distance 0, they're at the end of this slide, we would need to find the difference between where d is, whatever number value this is, and the origin here, which is at 0, 0. Okay, so right here we're at the end of this slide, so that's 0 on the x-axis, and then the slide is at some height, which we don't know. Okay, so basically what we need to do is we need to solve for d. So we're solving the equation, right? We're finding what are the values of, in the past we were kind of talking about values of x, but it doesn't matter what the variable is. In this case, it's d, and we need to solve for those values. So now what I would do here is, even though it doesn't tell you, what I'm going to do is I'm going to use factoring, and then we will confirm it using our graphing calculator. Okay, so here you can see right away that we have 1/6 and 1/6 in front of our variable. And remember, like I mentioned in the last lesson, you want to try and avoid having fractions in front of your like x squared value, which in this case is d squared. So there's two ways you can do that. You could either multiply the whole thing through by 6, or you could divide the whole thing out by 1/6. Okay, so when I did this one, I actually ended up dividing it out, so -1/6, right? Because make sure that you keep this sign with it. So if it was -1/6, you want to divide that whole thing out. So if we divide -1/6 by -1/6, we have 1, which leaves us with just d squared. And then same thing here, minus d, because we have another -1/6. Oh, sorry, but it's negative divided by negative, so we need to make that positive. And then we have 2 divided by 1/6. So if you were doing that in your calculator, it's just going to be 2 divided by bracket -1/6. Okay, and so that gives us -12. So we're going to do -12 there. And then we want to set that equal to 0, right? Because when we're solving for the variable here, then that means the equation has to be equal to 0. So now that we have that, we can look at basically factoring this. So remember, when we're factoring this, we want to find two numbers that multiply to make -12 in this case, and they need to add to make +1 in this case. So what are numbers that multiply to make -12? We could have 6 times 2, and because we need to add up to +1, neither one of these is going to work, obviously, because you're going to end up with 4. So you're either going to end up with, if you had -6 plus 2, you're going to end up with -4. If you have +6 minus 2, you're going to end up with +4. But we can tell from this that we're going to want the smaller value to be negative, because we want to end up with a positive value there. So the next option would be 12 divided by 3. So if we have 4 times by -3, we end up with 4 plus -3, which gives us +1, which is what we wanted. So this is going to be our correct set of numbers. So remember, that means we just divide this bracket up using those numbers, and we'll keep this number on the outside here. So -1/6 d plus 4 d minus 3. Okay, and so basically what we've found out is that our roots of our graph are d is equal to either, now remember when we're talking about the x-intercept, if you have a +4 here, then it's actually talking about -4 on the x-axis. So d could either be -4 or +3. So the important thing with word questions then moving forward is that we need to think about which answer makes sense. So if we have the base of the slide here and we have an x-intercept here at -4, 0, and this one here is 3, 0, we need to think about which one would make sense. Well, if the base, like the end of the slide, is here and the person's going to keep going out, it would not make sense to have a negative distance, right? They're not going to go back behind where the end of the slide was. So +3 is the one that makes sense. So then you would give a nice written answer, kind of like the slider lands 3 meters from the base of the slide. The base of the slide. Okay, so that'll be our final answer. All right, let's have a look at one that's a little bit more complex. The length of an outdoor lacrosse field is 10 meters less than twice the width, and the area is 6,600 meters squared. Determine the dimensions of an outdoor lacrosse field. So again, with this one, I always find with these word problems, it's best to visualize it. So I mean, I guess it depends a little bit on how you learn, but personally for me, I always like to draw out what it is. So I know that any kind of a sports field is going to be a rectangle, so I can kind of sketch that out. And let's see, they're saying the length is 10 meters less than twice the width. So with questions like this, you want to figure out which one is the kind of like the one where you just have a single variable, and then which one is the one where you have more than that. So we're told that we have some width, and then if we want to find out the length, we have to double it and subtract 10 meters. So we can start out with just width as a variable for this side, but the long side is twice as long, so 2 times by w as the width, right? Twice the width, but minus 10 meters off of whatever double that width is. So then I have to do minus 10. And that's how we develop kind of like really simple equations to represent these kinds of scenarios. So you can actually see I ended up putting that in here ahead of time. So it's kind of a cheat, but hopefully you guys could figure that out even if I didn't have that there. The other important thing is just remembering your formula for area. So area is length times width. Okay, and so let's see, determine, yeah, so we want to figure out the dimensions. So basically we want to figure out what is the length and what is the width. We're given the area as 6,600 meters. So if area is length times width and area is 6,600 meters, the next thing we want to do is use these like expressions that we've come up with for the dimensions to make an equation basically out of this, right? So we know that area is equal to length times width. We were given a number value for the area, so we can plug that in. And then for the length, we want to fill in the equation we came up with, 2w minus 10. And then width was just width. Once we have that formula kind of laid out, we want to start. The first thing we want to do is basically like expand and simplify. So we want to make sure that this is as simple as possible. So 6,600 can stay. I'm not going to keep this unit in value in there. Actually, it should have been meters squared because I just want to work with the numbers for now. So with the sets of brackets, remember you have to multiply everything together. So that's pretty easy in this case because it's only two things. So 2w times by w is 2w squared, and negative 10 times w is negative 10w. Okay, so now I have values. Now if I'm looking for the dimensions, essentially what I'm doing is I'm starting by, that means I'm solving for w, right? I'm solving the equation. And remember that in order to solve the equation, it has to be equal to 0. So that means we need to move this 6,600 away so that we have 0 on this side. So if we have plus 6,600 now, to move it to the other side, we need to subtract 6,600 from both sides. Okay, and so then that gives us 0 is equal to 2w squared minus 10w minus 6,600. Okay. now we can look at, let's get this a value away from there. So we can divide 2 out. So we can say 2w squared minus 10 divided by 2 is 5w. 6600 divided by 2 is 3300. And then we just want to work at factoring, so finding values that multiply to 3300 and add to -5. And so basically what I did is I started pretty big. So let's see, we want to multiply to -3300, and they need to add to -5. So the first one I did was 3300. 3300 divided by 100, I think I did. Yeah, so basically I know 100 times by 33 would give me, I want a negative value, so that means that my bigger value should be negative. So -100 plus 33 gives me -67, so not even close. Let's see, so that was using 33. Let's try, because this is an even zero number, let's try 50. So 3300 divided by 50 gives me 66. 66 times by 50 gives me 3300. -66 plus 50 is going to give me -16. So that's getting closer to -5, but not quite. So what would be the next thing? Let's try 60. 3300 divided by 60. 60 times by 55. So we'd need -60. -60 plus 55 gives us -5. Okay, so some of these, you know, like depending on where you're at with your ability to guess your multiplication and stuff, some of them might take you a little bit longer, but just kind of pay attention to the pattern. If your addition number is getting closer, like so we started at -67, which was quite a bit too large in the negative sense. If your numbers are getting closer, because our next one was -16 when we made the second number bigger, then you know you're getting closer. So then you know you're going to have to keep jumping up, right? So the next one we tried was like 60, and that got us there. So now we know that our numbers are -60 and +55. So basically when I solve for this, it's going to be 0 is equal to 2 times by w minus 60 and times by w plus 55. Okay, and so then remember that our roots, therefore, would be the opposite of that. So width could either equal +60 or -55. And so then you just need to think, would it make sense to have a negative width? Obviously not. So now we can say our width is equal to 60, and the units that we had were meters, so keep that. Length, we still have to do our calculation using our formula that we came up with. So it's going to be 2 times by the width, which was 60, minus 10. And so we can say length is equal to 120 minus 10, which would be 110 meters. Okay, so there's our dimensions for the field. All right, now this last one, I should maybe take this out so that you guys don't have that to see initially, because it's better if you actually have the skill to come up with those formulas on your own. So what you might want to do, because this one is quite similar to what we just did, see if you can figure this one out on your own. So maybe just pause the video and then come back and watch the solution to see if you got it right. So in this one it says the area of a rectangular ping pong table is 45 feet squared. The length is 4 feet more than the width, and we want to know what the dimensions of the table are. So again, we have rectangular table, pretty nice and easy, and we know that the area is 45 feet squared. The length is 4 feet more than the width. So again, the width is our baseline, the one where we just have a single variable. The length is the width plus, right, because it's 4 feet more than. So with these types of questions, you do want to be careful that you know what different words refer to like different mathematical functions. So in this case, if it's like twice the width, that means 2 times, right? But if it's 4 feet more, then it's plus. If it was 4 feet less, it would be minus, right? So make sure that you can equate the different words with the mathematical functions properly. Okay, so we have width, length. All right, perfect. And we want to figure out the dimensions of the table. So again, because we're given area, we know that we can look at area equals length times width for any rectangular shape. And we're given a value here for area. It's 45, which is equal to our length, which is going to be represented by W plus 4, and our width, W. The other thing to remember is that whenever you're setting up your formulas, you always want to, how do I say that? Like use if you have one variable, you want to make sure that that variable is the same in both of your equations. So you wouldn't want to set this to like something different. Okay, so make sure that all of your formulas that you come up with are in reference to the same variable. Okay, so now we have 45 is equal to, so again, we want to expand it. 45 equals W times by W is W squared. 4 times W is 4W. And then we want to set it equal to 0, right? So we want to get rid of this 45 by subtracting it off. So we're going to say 0 is equal to W squared plus 4W. And this was positive 45, so it's going to be minus 45 when we move it to the other side. And then we just need to look for numbers that factor to make 45. So I'm going to put my little factor table up here. They need to multiply to negative 45, and they need to add to positive 4. Okay. So for me right away, I would personally think with 45, 5 times by 9. And then, of course, 9 minus 5 would give us 4. So if we make that a negative, 9 plus negative 5 is going to give us positive 4. So that one was one of the ones that's nice and easy to figure out right away. So our numbers are negative 5 and positive 9. So we can say 0 is equal to W minus 5 and W plus 9. Okay, so basically that means our roots are positive 5 and negative 9. So again, remember, it does not make sense to have a negative dimension. So that means that our width is going to be plus 5. And remember to include the units. So this one was in feet, not meters. So you have a width of 5, and then our length is equal to the width, which is 5 feet, plus 4, which gives us 9 feet. Okay. And again, you can check the filled in notes in order to see kind of the proper way that you would want to write that written answer out in a exam. All right, so you guys have some practice questions to try here with the word problems and different types of factoring. And next time we're going to look at solving quadratic equations by completing the square. So I'll see you then.